I'm here with Yash Patil. Yash Patil is the CEO and co-founder of Applied Compute. Applied Compute works with companies like DoorDash, Mercor, and Cognition, and turns expert data into autonomous agents using continual learning and reinforcement learning. Yash and his co-founders were previously at OpenAI, where they were behind things like O1 and Codex and running reinforcement learning at large scale at OpenAI. Yash, tell me a little bit about your work at Applied Compute. Tell me about, how you think about continual learning, reinforcement learning, all these new types of, AI workflows and agents. Like, what is the problem you're trying to solve?
As these general models improve, it kind of is like a tide that lifts all boats. And what becomes really important is how companies are able to sort of differentiate themselves when it comes to building like the best AI systems for their work.
Yeah.
Intelligence shouldn't be rented; it should be owned. So actually taking everything that's special about your company, your institutional knowledge, how you do work, and imbuing this into a system that's non-static is basically what we focus on. So that's a lot of, learning from production usage. So having humans interact with agents, taking those production traces and building continual learning systems, and also taking the proprietary data that companies have and building the best model in the world for the tasks that are pretty critical to their business.
That's awesome. Can you walk me through like Applied Compute? Like, how did you build the underlying infrastructure? What are the different pieces of it? What role does Modal play in this?
Yeah, so we basically have structured our platform around sort of three main pillars that we think are the most important when it comes to building agents. So that's, actually putting the agent together, observing the agents and like how they behave, and then improving them. So we use Modal in our RL stack to actually like back all of the traces that are being rolled out during training time. We use Modal when we're actually building our observability functions that need to run massively parallelized across thousands of traces. And then for improving the agents, we actually can host our models on top of modal inference, power these agentic products, and capture those traces to later turn into synthetic data.
That's super cool. You're building something you call specific intelligence. So maybe let's start off by could you describe a little bit for people who don't know about your field? Like, what is specific intelligence?
Yeah, absolutely. So specific intelligence, what we like to describe it as is it's AI for one company, which is kind of to say that as foundation models continue to improve at such a rapid pace, what becomes most important is retaining your competitive edge and actually specializing at what you're really, really good at. So what we do is we work with enterprises to take their proprietary data, workflows, subject matter expertise, and turn that into AI systems that can actually improve the more they're used. So, we kind of work with customers to post-train custom models and set up continual learning systems.
Nice. That's awesome. Yeah. You work with customers like DoorDash, Mercor, and Cognition. What's a typical customer, and why do they come to you to get your help with this?
So our customers are typically at the leading edge of sophistication when it comes to AI. And they've been working with these language models as soon as they come out of release. And they've kind of pushed them to their limits, and they're looking to go even further than what they can get off the shelf with the frontier models. When we sort of talk to them, it's very clear that there's this Pareto curve of cost and latency and sort of intelligent performance. And not everyone is on the curve from off the shelf. So people like to spend a lot of effort in terms of optimizing specifically for what they're looking for. A lot of really great model training comes in coupling your product with the actual agent that's backing it. So we work with them to sort of specialize these agents for particular use cases.
Nice. And are these cutting edge companies, or how do you think about the sort of maturity curve? Where do companies that maybe starting out with, OpenAI or Anthropic's model, how does that journey look like from there towards using something like Applied Compute?
Totally. Yeah. So we're huge fans of the frontier models coming out of OpenAI, Anthropic, Gemini, XAI. They're extremely powerful. And I think for companies that are starting to sort of deploy AI in their organization, they're a great sort of first step to capture a ton of low hanging fruit. But once you start to really push these into your workflows, there's often times when you want to imbue some of that special knowledge or institutional knowledge that you have in your company that actually makes you unique. And that's kind of when we see customers approach us really around hey, I have this I have this process. I want to build a highly specific eval to it. How can I go and make the best agent possible to perform on my specific task?
That's super cool. And like, what are some success stories? Like, what are some of the customers you work with, and how do they see the success that comes from this, deploying this in production?
Yeah. So like you mentioned, we're working with a couple of customers like DoorDash, Cognition, Mercor, and essentially the way our sort of engagements work is, we kind of go deep with their internal teams on what the task or sort of workflow is that they're trying to deploy an autonomous agent on, and sort of define that in a high quality eval. And then once we train a model, we're also focused on continuing to improve the model over time, or the agent over time. So that's like capturing all of the production traces, how humans interact with these models, and turning that into the context memory synthetic data that we need to continually improve these systems.
Nice. And what are the results that these customers see in production? Is it, better customer support or better code models, or like what are some of the things that people see when they put these in productions?
Yeah, so for DoorDash specifically, we were able to train a SOTA model on some of their merchant onboarding tasks. So particularly, this was like taking a complex menu that someone might upload an image of and turning that into the structured representation for a DoorDash storefront. And for Cognition, that team's like amazing. They're really, really at the cutting edge of what you can do with these models. And we've been going deep with them on creating specialized agents for different workflows. We recently sort of partnered up with them to create this bug catching agent that can actually run super fast, kind of almost in real time. It's a custom model running on Cerebrus hardware. So you can actually get bug catches, seconds after you save code.
Yeah. Do you think all companies will start out with sort of proprietary APIs and eventually kind of go down the curve of starting to use reinforcement learning or continual learning?
Yeah, totally. I think like the way this kind of plays out is every company is going to start to build their own intelligence stack, just like they did with their software stack. And kind of at the base, you're going to have these extremely powerful, versatile frontier models that are coming out of the labs. But then, one thing I like to say is, as frontier models get really good, the floor rises, but specialized models and sort of custom post-training sets the ceiling.
Nice.
So customers that are kind of in competitive environments where, they really need to have the differentiated product or imbue what makes their company amazing into their AI systems are going to lean towards like custom post-training, building these continual learning loops, evaling everything, and sort of having a good understanding of like what is good and bad to them.
That's awesome. That's awesome. And what do you think the role of open source models plays this? Is that absolutely critical that we have continuously better open source models to base this on?
Totally. I think it's super important that the open source models continue to improve. And really it's because I think it stacks super well with the frontier models. Is like, these frontier models are going to be like the workhorse models for a lot of things, but where it matters to be able to sort of touch the weights, actually change how these models are thinking about problems that you task them with, you're going to lean on open source a lot. And sort of the way we think about the different places for modifying an agent is you have like the model layer, which is like you're doing some sort of custom post training. And then you have like the harness and context layer, which is like what a lot of people are exploring right now. People use Modal, like your Sandboxes product a ton.
Talk about that in a second.
To create like these like complex environments, because an agent is really much more than just the model. It's also everything around it that actually makes it useful.
Nice. And in what domains do you think that the most success has been so far? I mean, people talk a lot about customer support, coding model, obviously. What are some maybe unexpected domains or some new domains that are popping up where you think this carries a lot of promise?
Totally. Yeah, I kind of like to say that, use cases where it's high volume, high context, or high consequence, or where, really investing in some sort of custom model training matters. Like you said, coding and customer support are kind of like the highest volume use cases right now. But use cases in, sort of fraud operations, legal, finance, those types, you often need to be a domain expert, not only in the type of work that you're doing, but knowing what good and bad looks like at your specific company and actually creating that reward function for for,
Yeah.
whatever organization you're
And,
representing.
and how do you go about that? Like,
Yeah.
how do you define that reward function when you work with the customer? Like, is that,
Yeah.
that must be a lot of work initially to kind of design that.
Totally, yeah. So the way our company works is we have like a huge forward deployed element actually.
Yeah.
So we come in with an extremely powerful platform with all the services you need to be able to train and build
Nice.
really powerful evals. But a lot of our applied researchers are working directly with internal teams to take their proprietary data, turn it into these high quality evals and training pipelines, and then push train models.
That's awesome. That's awesome. That's super cool. Let's talk a little bit about sandboxes. Like, what role do
Yeah.
you think sandboxes play in this world of reinforcement learning, continual
Yeah.
learning? Like, why is it, is it an important building block?
Yeah, I think it's one of the most important building
Yeah.
blocks, if not the most.
Yeah.
And we were talking a little bit about it off screen, but I think the way agents are kind of going to be deployed in the wild is almost always alongside an execution environment.
Yeah.
And the reason is it's multiple reasons. First principles is like a lot of times these models are doing calculations and
Yep.
sort of things that can be well represented in code, and code gives you determinism, right? So rather than having models do math in token space, you give them access to Python code to
Yeah.
write a function, calculate something. And then another one is just, this is kind of what the sort of ecosystem as a whole has agreed upon as one of the best modalities for having agents do work. So it's what the frontier labs are really specializing their models on. So, coding capabilities is going to be a great prior of any sort of frontier or open
Yeah.
source model.
And what sort of challenges does that require from an infrastructure perspective in terms of managing these sandboxes as a part of a reinforcement training loop or things like that?
Totally, yeah. So kind of at a high level, the way reinforcement learning works is, you take some problem that
Yeah.
you built a replayable environment for,
Yeah.
and you actually have the model attempt that problem many, many times. So,
Okay.
that this can be like hundreds or thousands of times in parallel. The model goes, tries the problem, and then gives some sort of final output. And you can essentially assign a reward function to that rollout. So
Yeah.
grade the model's code, like how many unit tests did it pass, or look at the model's final answer and compare it against a rubric of criterion. And then you get this like distribution of rewards. So what's super important is actually being able to replay an environment over and over again. So
Yeah.
these execution environments are great, specifically like the Modal sandboxes, because they're ephemeral, they're really lightweight, and
Yeah.
you can quickly hack together kind of any environment that you want.
Nice.
Yeah.
And are there like specific requirements on the sandbox primitives themselves, like
Yeah.
snapshotting or determinism? You talked a little bit about determinism. Like, what are the sort of constraints or requirements of reinforcement learning specifically on sandboxes?
Totally, yeah. So I think there's a couple of things. So
Yeah.
those things that you mentioned, really good for creating environments that you can replay for RL.
Yeah.
But also, just performance. Performance really, really matters because, what's the most expensive thing when you go to train models? It's GPU time. So the more you can kind of make the CPU stuff really, really fast, the better.
Yeah.
Yeah.
And when you talk about performance, is that in terms of scale or latency or both maybe?
Yeah, exactly. It's so when you're rolling out, a lot of samples at once, basically, you spin up times for sandboxes. There's like a P50 latency, P90 latency, right?
Like how many sandboxes do you spin up?
So, for large scale training runs, batch sizes can be in the thousands of rollouts. And the rollouts are also getting longer and longer horizon, right? So as these agents are able to work continuously for, call it like 1, 2, 3 hours.
Oh, wow.
Yeah, I mean, like the way these things are going is they're going to be sort of cranking inference all the time. So having a robust system where, your sandbox doesn't fall over, or if it does, it can quickly recover is pretty important.
Nice. That's awesome.
Yeah.
Tell me about how you came about using Modal. Like, did you look at other infrastructure? Did you have your own framework? Like, how come you ended up using Modal for some of this?
Yeah, so we were kind of doing a little bit of a test against all of the available sandbox providers at the time. And, when I was actually at OpenAI beforehand, we were doing similar types of RL training, and we're looking at kind of what's the best stuff out there. And Modal was like clearly very flexible, kind of was structured in a way where we could build these complex environments, and then also really focused on performance and reliability. So
Nice.
our journey was kind of basically trying out a couple
really?
of these providers, and the obvious. I think
Yeah.
the reliability, speed, and also
Yeah.
honestly the support from your guys' team got us really excited about.
That's awesome.
Building a model.
It's good to hear.
Yeah.
What are some unique challenges when you're thinking about how to scale reinforcement learning with customers that maybe have more and more data and like more and more complexity to their environments?
Totally, yeah. So when we're building our platform, one of the core principles that we wanted to keep in mind is eliminating train test mismatch. So that means
Yeah.
exactly the environment that you train your agents in should
Nice.
be the environment that they go and do their real work.
Yeah.
So I think fidelity of environment. So how accurately are we able to mock all of the different systems
Yeah.
that an agent might be touching during test time really matters.
Yeah.
I think another thing, like we were talking about before, is reward hacking, right? So if you apply a ton of optimization pressure towards a specific behavior, if it's not perfectly codifying what you're actually looking for, you can end up in these weird local maxima. And then also just the actual work of going and understanding what good and bad looks like, which is a lot of what our team does and the infrastructure that we build for learning from production traces and sort of learning from user feedback. That informs the evals and the training data that you're actually going to go and use to make
Nice.
these models real.
Nice. What about sort of on the more technical side of like scaling the infrastructure of this, more GPUs, more data, more sandboxes? Like, how do you think about some of the complexity
Yeah.
around like, running that at very large scale?
Yeah. So like as for example, with the environments, right?
Yeah.
If you're actually mocking, entire systems for companies, right? So, maybe they have a Salesforce or they have a Slack or something like that. These things can get quite heavy, but again, you still have the requirement of having them be replayable. You're not actually touching a production service during training. It's a mock service.
Yeah.
So you need to make sure that during train time, you're not actually bottlenecked on any of the CPU stuff, and you're actually using your GPU time effectively, because that's what's expensive today, and kind of what people want to scale out is GPU compute. Yeah.
Nice. Awesome.
Yeah.
And how does Modal help you with this?
Yeah. So I mean, Modal gives us the powerful building blocks for making all of this happen. So we're big users of the Sandbox product that you guys have, and then also Modal functions themselves give us a cheap way to do a lot of computation massively in parallel.
That's awesome.
Yeah.
You're obviously building something very complex in AI. Like, how do you think about, growing the team and finding the right talent? And I heard you have a very strong team.
Yeah. So I think like one thing that's really important for our company is being able to deeply embed with customers and resonate with their problems and actually go and build solutions that are specific to them. So when we think about research, it's actually very much from the lens of applied research. So what we're spending our time on is not greenfield problems. We think the foundation labs are putting a lot of effort and resources towards that, and that's amazing for the world. We really want to be the bridge between frontier research and real world problems. So when we think about hiring, the candidates and the people we're most excited about really like interfacing with customers, rolling up their sleeves and doing a lot of this somewhat like schleppy type work where you're actually going deep, understanding the problem and connecting these like super powerful models with things that'll actually move the business forward.
And I heard there's a bunch of mathletes.
Yeah, exactly. So one interesting pocket of people that we found a ton of success with is these IOI or IMO type medalists who are super excited about research but really want to apply it in some meaningful way.
That's awesome. I guess like one question I had, what do you think are domains for which reinforcement learning, continual learning works really well for versus like what do you think are domains where it might be more challenging to make it work?
Yeah, so I think the domains where it works really well is like highly judgment-based tasks where you actually need to. So this is actually the interesting thing is people think about RL a lot of times as like super verifiable, but the space of what verifiable means is continuing to broaden. So at the very start of training these like smart reasoning models, it was all math. So it was like competitive math, where the answer is like a number and you're basically checking if the model outputted the right number. Then we graduated to things with a little bit more surface area like code, but you could still test this with unit tests. Now we're seeing verifiable domains mean like places where you can build really complex rubrics for based off of subject matter experts. So, you know, if you have a complex legal question, a senior lawyer can sort of say, hey, this is what a really sophisticated answer to this question would hit on in terms of the criterion. And I think what you're going to kind of see is that people are going to start encoding what they think is good and bad into these types of like soft verifiers. Where, you know, the answer to this legal question is specific to how we think about this legal question at this law firm. So I think what's going to happen is right now everyone kind of thinks things are like, you know, strictly deterministic verifiable, but people are going to start encoding their own notion of what good and bad looks like.
Interesting. What's a domain where it might be more challenging? What about gardening or cooking or?
So I mean, I think a domain that is challenging for reinforcement learning is like customer support, right? Like, so customer support, you can obviously verify whether the right tool calls are being made or, you know, if the agent is eventually going and doing the right, you know, modifications to the database or whatever. But what is harder to tune is kind of, hey, what are the policies of our agent? How are we actually understanding whether the customer was satisfied or upset at the end of the conversation, and then turning that into reward signal that you can then train these models on.
Can you ask the customer in that case, or is it then do you end up kind of hill climbing in a way where it maybe isn't desirable?
So this is kind of the whole difficulty of reward hacking. Right? So when you have a powerful hammer like RL, which optimizes directly into whatever reward you know, training signal you're outputting from your grader, you can end up in these sort of local maxima where a agent turns out to exploit some sort of very particular.
It gives refunds to everyone.
Exactly. It gives refunds to everyone, or it gives people a bunch of free stuff or something like that, which will obviously, if you're optimizing towards user satisfaction, be good for the customer, but not good for you.
Thanks a lot for doing this.
Really appreciate it.